Hi class, today I am not here, but I'm still going to teach you a bit about systems of equations and another way to solve them. And I think you're all going to like this method because it is reliant on the calculator. But before we get to that, I'm going to teach you a little bit about the different types of solutions that you could get when solving a system of equations. So, the word consistent means that your system has one solution, and that's all the types of equations that we've worked with so far. And then what that looks like when you graph the equations is you get two lines and they cross and they meet at a single point, and that point where they cross is their solution. If you try to solve the system of equations using substitution or elimination, you will get some value for x and you will get some value for y. Now, a system is considered inconsistent if it has no solutions. When you graph that system, that means that the lines are parallel, so they never cross. And if they never cross, they have no solution. What that looks like when you go to solve, if you're doing substitution or elimination, is that all of your variables are going to drop out and you'll end up with some sort of false statement, such as 0 equals 7. We all know that's not true, and that's the type of result you will get when solving an inconsistent system. The third and final type of system you could have is one with an infinite number of solutions. That's called dependent. When you go to graph this system, it turns out you'll only see one line. That means that both of the equations in your system were actually the same line. And if you try to solve that system using an equation, you will end up with a true statement. All your variables will drop out, just like they did in the inconsistent case, but then you'll be left with something true, such as 2 equals 2, 5 equals 5, 0 equals 0. All of those things are potential solutions when you have a dependent system. So those are our three different kinds of solutions we can get. We're still going to keep working with consistent because those are the most interesting case. So the solution that I mentioned. And that new method of solution is called using matrices. And matrices is the plural of the word matrix. A matrix is an n by m array of numbers enclosed in brackets. And the dimensions of the matrix show you how big it is. M is the number of rows, and N is the number of columns. So if you have a system of equations, such as the one you see here, the first thing you want to do is you would want to create a matrix of the coefficients. Now, if you recall, the word coefficient means the number before a variable. So my coefficients for this system are -8. There is a 1 right here in front of the y. So I have a 1 there. And then I have a -4. And then for my second equation, I have a 10, a 5, and a 30. I would like to point out that in order to use this matrix method, your equations must be in standard form. So this is the coefficient matrix because we pulled all the coefficients out of our system of equations. We can kind of draw a dotted line there to show that this part of the matrix, these were the coefficients of our variables, and this part of our matrix, those were the things on the other side of the equal sign. So the dotted line is located where the equal sign was. And we call this an augmented matrix because the coefficients and the thing on the other side of the equal sign are all together in one matrix. So now I'm going to go through a series of steps on the graphing calculator to show you how to put this into the calculator and produce a solution matrix. And then we will pull out the solution of the system from the solution matrix. So hold on a second and get your graphing calculator handy. Okay, so with your graphing calculator, you would like to hit second matrix. You can see matrix here in yellow above this x to the -1 button. So you're going to hit second and then matrix. And you may have some things in there already, you may not. You are going to go all the way over to edit and you're going to hit enter. And on your first matrix, we need to put in the dimensions. So the dimensions are the number of rows by the number of columns. So the matrix that we just created has 2 rows, so I'm going to put a 2 first. I'm going to hit enter. Then I'm going to put a 3, and I'm going to hit enter. And now it has produced some blanks in here that are 2 by 3, which is the same dimensions as the matrix we want to enter. If your calculator has never held a matrix before, these may all be zeros. Mine has what I last used in it, but that doesn't matter. I'm going to replace those values. So I'm going to put into my matrix the values from my coefficient matrix that we just wrote. So I'm going to put in -8, enter, 1, enter, -4, enter, 10, enter, 5, enter, and 30, enter. And now that I have that matrix, I'm going to hit second quit. You can see quit is right next to the second button. That just gets me out of the matrix window. Now I'm going to hit second matrix again, and I'm going to go over once this time to go to math. There's a lot of different operations that you can do on a matrix. We are going to do something called reduced row echelon form. So what you need to do is arrow up, actually is faster, arrow up to option B, which is ref. And I need you to select option B. Then you have to go back to matrix again, so you're going to hit second matrix, and you're going to select matrix A, which is where you typed your data in. You're going to hit enter, and you're going to get this out. This 101014, this is your solution matrix. So go ahead and write this matrix down under solution matrix in your note packet. So now to finish things off, we're going to write down our solution matrix, which is 1, 0, 4, 1, 0, 1, and 0, 0, 1, 4. And again, I'm going to put in a little dotted line here to identify the difference between my identity matrix and my solutions. These here are my solutions. What this tells me is that when I have 1 x's and 0 y's, I get 1, and when I have 0 x's and 1 y, I get 4, which means that x equals 1 and y equals 4, so my final answer as a coordinate point is 1, 4. Now I can use a matrix just like this to solve a bigger system that has 3 equations and 3 unknowns. I just have to add an extra row and an extra column to my matrix so that when I go to put it in the calculator, I'll put in a 3 by 4 matrix instead of a 2 by 3 matrix, and the process is exactly the same. You're going to try that now on some practice problems. Good luck.